Hi, this is Veer Raghav Prasad, and I'll be talking about the future technology of learning. So, knowledge management is the process of capturing, distributing of knowledge. There are three kind of knowledge. First is the explicit. Explicit is the one which is documented. Implicit knowledge or which exists but it is not documented. So, the tactical knowledge is something which you gain using your experience is the tactical knowledge. So this is the mind map that demonstrate how human acquire the knowledge. There are four kind of different ways that human can gain knowledge. One is the logical. By using logical reasoning or from logical skills, human can gain knowledge. And the second is the verbal. Verbal is something by speech or by writing or by gestures, human can acquire their knowledge. Third is the visual. Visual is by pictures, images, or by any 3D objects or by movies they get their knowledge from. And the last is the physical. Physical is by body action, hand sense, and by touch they can get their knowledge. And this is the mind map which demonstrate the human learning methods. This mind map will demonstrate how the knowledges are being stored in a system. So I'll be using system development lifecycle for for demonstrating how knowledge is being stored in a system. So we'll be comparing three kinds of methods. One is the methodology, that is one is waterfall, and iterative and agile, and the last is the future knowledge management. Will be discussing how it will be done in the future. And first is the waterfall. In waterfall model, it has a definite scope and it is instructor driven, and the knowledges are being documented in file systems. And the second is the iterative. In iterative, scopes are verified and it is always used for some bigger problems. The iterative model, uh, and the knowledges are documented using self-generated method and using e-learning techniques. Third is the agile. Agile is the one which is being currently in use, and it has an open scope and knowledges are being documented in Wikipedias and social medias like YouTube or Facebook, and even using ad hoc learnings. The future learning which I'm proposing, it could be using holograph or using virtual environment or natural language processing or even using genetic learning. This is what I'm proposing for the future knowledge management. The previous slide we saw about the different kind of methodologies which knowledge can be documented in a system, and in this slide we'll be talking about how humans acquire knowledges from the system, and we'll be comparing for the waterfall model for that. In waterfall model, as I said before, the knowledges are documented in files, and since it is documented in files, human acquire knowledge by using some kind of instructors or by verbal understandings or by written knowledge. And always the waterfall model is instructor driven. The second is the iterative model. In iterative model, the knowledge is stored using software development, some kind of external softwares. So how the human get the knowledge using iterative model is using e-learnings or by kind of like experiences, day-to-day experience they get their knowledge from. The third is the agile methodology. In agile methodology, it is one of the rapid kind of methodology. Knowledges are stored using Wikipedias and in any kind of like social medias. And so human get the knowledge by reading the wiki contents or by watching some videos in social networking or by YouTube or something like that. And third is the one which I am proposing is future model, how the knowledges will be documented. It could be using virtual environment or using molecular level storage. That is, they can get their knowledge using holograph or virtual learning or genetic learning. So let us see in future how the knowledges will be documented. And this is what I am proposing. Let us imagine a holographic image. So when you can generate a holographic image, imagine when you are able to transfer or push the image to a 3D printer. So when you are able to do that, the 3D printer will give you a will give you a real object. That is where you can imagine something, and when you push it to the 3D printer, it gives you a real object. And knowledges can be documented in such a way in future. And this is one of the technique I'm proposing. And this technique can be used even for home equipments, office, or some kind of manufacturing and production even. And we will be seeing a video that demonstrates the virtual environment, what I said before, how a virtual image can be transmitted to a 3D printer, and we'll be seeing a video of the virtual image, and in future it can be sent to a 3D printer, but now we will be seeing a video of the HoloLens, which makes the image or something to view it virtually.
Hi, this is Lance Yolanoff, Chief Correspondent for Mashable at Microsoft Build 2016 in San Francisco. We're here to try out the new HoloLens Developer Edition. This is the first time we're getting to take photos and videos and even unbox the $3,000 device. Don't get too excited. It's only for developers and businesses. Consumers are going to have to wait. So on the wall there, I've got Microsoft Edge web browser. I can air tap right in the, so I'm air tapping in the address bar. So now I've actually got a keyboard below, and you can attach a Bluetooth keyboard so you can type, but if you're going to just use it virtually, you basically are selecting one letter at a time. So you could also probably just talk to it. There's a microphone right here, so let's tap that. The Weather Channel. Okay. There's a dude talking to me right there. He's actually full size. It's right here.
Yeah, this is the video that demonstrates the HoloLens, which is designed by the Microsoft. And imagine these kind of images when you see it virtually and when you are able to transmit to an external printer, and when it prints it, how uh, how amazing it will be. So this is one of the technique I'm proposing. And let us see one more video which demonstrate the 3D printer as well.
Hi guys, this is an M3D Micro 3D printer. Now you will not need a magnifier to see it, it's right in front of me. But it's indeed very small. In fact, the smallest I've seen compared with others. Now the Micro also have a small build size. For example, this queen right here is about as tall an object you can build. By the way, this took the printer 3 hours to make. And this fat king right here, 9 hours. So it's slow, about as slow as other printers of the same technology called fused filament fabrication. Now, the print quality is also that of this technology. You can always tell that this is a 3D printed object, and there's no way I can make a convincing replica of any part of my body, even this little thing. It's just too smooth and gorgeous. Anyhow, as for print materials, the printer use standard filament come in spool, only print directly from a computer. There's no SD card or USB slot. And the computer have to be connected to it the entire time of the print. So if you print a large object, make sure you cross your finger. Now this is what happened when the printer was disconnected midway. The print here has no head. So all things considered, this is a
So you saw a 3D printer, and this 3D printer is connected to a computer. Imagine when this 3D printer is connected to a HoloLens or a hologram. So directly you can transfer the image to the 3D printer and the object will be printed virtually. And this is one of the knowledge management technique which could be introduced in the future. And here we'll be talking about the research ideas for the virtual holograph. So when you want to go to Rome or some kind of tourist places where you don't want to travel, so you can use the hologram or you can use the HoloLens and you can see the places virtually. And this could happen in future. You can sit in your home and you can visit places. And if you want to build some kind of home and if you don't want to invest, how interesting is that? So you can even do that using a virtual hologram. So this could be implemented using the hologram. And the second future knowledgement idea I'm proposing is the molecular learning. So molecular learning is something like when memories can be injected to human brains and they can acquire knowledge. So that will be very simple, right? So when this could happen even in future, and let us see what are the advantage or what are the research ideas that could be developed using the molecular learning or molecular techniques. So if you want to memorize something, you need to spend a lot of time in reading books, or you need to go through it again and again. And if this kind of molecular learning comes into existence in future, you can just inject the memories or some kind of data which you want to learn inside your brain cells, and you can acquire the knowledge. And this is one of the technique. And if you want to forget some kind of incidents in your life, in your rest of your life, or something like that, you can delete the memories just like that using molecular learning or molecular techniques. So this is one more idea that could happen in future, and this is one of the knowledge management technique that can come up in future as well. Here we'll be seeing the performance of the virtual learning, comparing the traditional learning with the virtual learning. In traditional it is hard, and virtual learning, since it is virtual, it is very easy to understand as well. And the knowledge transfer, so you need a external person to transfer the knowledge using the traditional techniques, but in virtual you can see everything as an object, or you can virtually see with your eyes. So the learning is quite simple. And time consumption is more in traditional. When you compare it virtual learning, yeah, the time consumption is it is like it is more, but when you see it once, you can gain the knowledge for a longer period of time. So in molecular learning, we will be comparing the molecular learning performance with the traditional and the future molecular technique. So for learning in traditional, it is hard, but in molecular, it is very easy. It takes just a second to do it, and the understanding is very simple. But in traditional, it is quite hard. So knowledge transfer is nothing. You're just injecting the memory inside your brain. So it is going to be very simple as well. And the time management in the traditional technique, you need to keep on going through the document again and again. So if you forget it, you need to again re-go it. But in molecular learning, that is not the case. Once you inject it, it will be forever, and if you forget, you can inject it once again. So that is the performance comparing the molecular learning with the traditional learning. So here we will be comparing traditional, virtual, and the molecular learning techniques, uh, their accessibility metrics. So for traditional, it makes you really tiresome when you keep on going through the document. Virtual learning, it also makes you tiresome, but it is interesting. It will stimulate interest in you. The molecular learning, it doesn't makes you tired, or it doesn't makes you anything. It is going to be very simple. That is that with the molecular technique. And the usage, when you are able to understand the document, you will be able to implement it in traditional. In ritual, it is not the case. Since it is ritual, you will be able to understand. And in molecular, in molecular, it is going to be very simple. When you inject it, you will know what is happening. So the storage in document, in traditional, it takes a lot of space, since the physical space. But in the virtual technique, it is going to be everything inside the memory. So the space storage is simple. And in molecular learning, it is going to be in molecular level, so that will be more simple. And the implementation in traditional is very easy. The virtual, that is quite hard. It is bit like complicated. But the molecular level, when you compare, it is very more complicated. And the cost in traditional techniques are low. In virtual, it is more cost, and in molecular level, it is very expensive to implement it. Let us see the risks that are associated with the virtual learning and the molecular level learning. First, let us see the low level risk for the virtual learning. So if there is any kind of like communication failure, it comes under the low level risk. And in molecular learning, to understand the brain structure, like how the human brains work, is a kind of risk. And what are the high level risk? So when a person is stuck into the 3D world, so how he will be coming back, since everything will be looking like a real object. So what will be the case in that scenario? It is a high level risk. In molecular learning, mm, when when you are injecting something inside your brain, and if the memories which are and because of the injected memory, what happens to the other memories if it is lost, and if you are not able to identify your relatives or your families, so what will happen in that case? It is a high level risk. So what are the implementation risks that are associated with the virtual learning? Any kind of like accidental scenarios, or any kind of like impacts that will happen when you're transferring the object from the virtual to a 3D print, or any communication failures, or those kinds comes under the implementation risk. And in molecular learning, when you're injecting something into your brain, whether the other cells will be affected or the old memories, whether it will be erased, or when you are extracting the cell from your memory to erase something, what happens to the other cells. So these are all implementation risks that are associated. So these are the risk analysis in virtual learning and the molecular level learning. And that's all I have for today. If you have any kind of questions, you can post it in the discussion board, or email ID is available. You can shoot an email. And these are the references. I just looked into it. And that's all I have. Thank you for watching the video and the presentation. Thank you once again. Bye.